Hi, you're watching Floyd Steinberg's YouTube channel, and today, this. This is a $20 smart ring, and I've converted it to a MIDI controller using JavaScript. And if you want to know how this works, please join me in this video. Here we go. Now, a lot of the things I'm going to show you are based on the work of Aaron Christophel, who recently became famous for running Doom on a toothbrush. But the whole idea for this video actually started when I stumbled upon this very cheap smart ring while searching for components on AliExpress. I immediately made the connection to that Roland MIDI ring from some years ago, and I wondered if I could do something similar with this cheap Chinese gadget. So I measured the circumference of my left ring finger with a piece of paper, and with the help of an online chart found out that ring size 10 is the one I need, and I placed an order. 1 week later, a tiny parcel arrived containing the ring, a USB cable and a short manual. The USB cable is for charging only, and it snaps to the ring with a magnet. The ring itself is one of those technological marvels we have come to accept as perfectly normal.
There are a few who can.
Outside is a layer of metal, and on the inside there are some tiny ICs and a battery cast into a layer of epoxy. Because of this, the ring is waterproof for everyday tasks. I wouldn't go swimming or diving with it though. The battery will last for a day or two when using this ring as intended. As a smart ring, this is surprisingly precise. Compared to the data my smartphone or my smartwatch are picking up, the ring is comparable in its assessment of steps taken, sleep length, blood pressure, heart rate and so on. The accompanying app looks quite nice as well, apart from its dodgy English. But we're not here for that. Let's use this ring as a MIDI controller. So with a bit of help by Copilot and some YouTubers, I wrote a small web app that I'll briefly explain to you now. Okay, let's take a look at the code itself. So this is a standard web page, so we have HTML code here and CSS to create a layout for our user interface, and a little bit more down we have the HTML itself, which defines all those buttons and select fields and input fields here. Of course, the most important part is the script itself. So let's take a look at what's happening here. We're asking the user to give us permission to access his MIDI devices and later his Bluetooth devices using the WebMIDI and WebBluetooth API. And what's happening here is once the ring is connected to this web page, it will start sending data. We're picking up the data with event handlers. Certain events that tell us about the rotation of the ring will then be transformed into MIDI CC commands. As a user, you can select the destination for the X, Y and Z axis rotational value the ring currently has. So for example, here I've selected CC72, which is release time of your sound. I've defined some values here for you to choose from, but if you need more, you can just enter them here by hand. And if you didn't know what each CC value does, there are lists on the internet. I will link in this video's description. So basically what happens if you connect the Bluetooth device to your computer is it will announce what type of device it is and what services it can provide. And then within your Bluetooth script, we can ask that device to please provide its services and the services characteristics. So you can see that here we have the services and the characteristics, and we're looping across all services found and then across all characteristics found within these services. And we're attaching an event handler to each characteristic. And the characteristic on this ring, for example, is its motion sensor, which will provide us with X, Y and Z data. So we can convert that to a value between 0 and 127 to send to a synthesizer. Now let's finally put this to a real-life test with my Yamaha Montage. Okay, so this is the setup. We have this personal computer here, and my web app is running on it, and I've selected the Montage, which is the synthesizer over here, to be the receiver of the MIDI commands sent by this smart ring. The smart ring itself is connected to this computer by Bluetooth, and its motion sensor is getting picked up when I move my hands here. The data produced by those movements is then converted to MIDI data, and when I play notes on this keyboard, I can use that data to, for example, control filter cutoff frequency or other things. And the easiest way for everyone to do that is to select the mod wheel and the expression pedal as a destination for the MIDI data the ring is sending. Here's a quick look at how I set up my synth. This is a simple saw wave, and we have both a high pass and a low pass filter on it. Here's a mod matrix entry that tells the synth to change the filter cutoff frequency when the mod wheel is moved. As the ring is mapped to the mod wheel on its x-axis, turning my hand should change the filter cutoff frequency. Okay, getting to this point took me roughly 1 day, and I'm really thrilled it kind of works as expected. But there's one problem left to solve, because this ring sends a packet of data roughly once per second, which is much too slow for precise and controlled movements. As you have seen in the video, my filter sweep there was really slow. So I'll have to look for a way to speed up data transmission on this ring. Another way to try to approach this problem is to add interpolation to my script, so let's take a look at that. Luckily, Aaron already solved the first problem and created a custom firmware that will transmit raw data much faster, and he also made a web interface that lets you upload that firmware to the ring. Best thing about this is the firmware is still compatible with the official app, so you can continue to use this as a health tracker without the need to reinstall the official firmware. So all I had to do now is to create a simple interpolation algorithm. I did this by introducing two arrays, target value and current value. The former is controlled by the ring. Whenever it sends new data, that value is stored as target value. The computer runs an endless loop now that will move the current value by one step closer to the target value in an interval you can define in my web app. This creates a simple linear interpolation and results in smoother transitions. Let's put it to the test. Okay, with the fast transmission firmware installed, here's an example with a digital audio workstation. Here's an app named LoopMidi, which will get the browser's MIDI output and redirect it to my DAW Reaper. I've set up the ring to send on CC4 as an expression pedal. In Reaper, I've set up the Jura plugin to map the expression pedal to filter cutoff frequency. Now let's play back a loop and move the ring, first without interpolation. Turning on interpolation makes the filter slider move much smoother. Yeah, and that's it for today. A $20 China Gadget smart ring, fruitfully converted to MIDI controller with some obscure scripting, and the help of other YouTubers. This solution still isn't perfect, because while the situation has improved drastically since installing the fast firmware and using interpolation, this still isn't quite as precise as it could be. And because this is an accelerometer instead of a precise positioning tool, you have to be be very careful how to hold your hand, so it's always adjusted in roughly the same way. Another problem I dealt with were frequent disconnects when a lot of other Bluetooth devices were around. But I feel the hardware is capable of more. For one, it can pick up this gesture, so we could use that to trigger MIDI notes, for example. That's a thing you can figure out at home. And I feel that installing a firmware on the ring which converts this into a Bluetooth MIDI device would allow for much more precise movements, so we can shake our hands and create vibrato or other modulation effects that need a little bit more precision. I won't do that, however. I think my task is to create YouTube videos and inspire you to explore things. So if one of you is smart enough to come up with a custom firmware for this ring, I think a lot of people would be quite interested in that. Yeah, that's it for today. Thanks for watching. Please consider subscribing. You can also support me on Patreon or become a channel member. So now we could try how an elongated arm gesture actually sounds like. As always, thanks for watching and see you again very, very soon. Bye bye.